Have you ever wondered how Google knows what you're trying to type, or how your favorite streaming service seems to magically know what you want to watch next? Well, it's not magic, it's artificial intelligence at work. In this video, we're breaking down how AI and machine learning work in the simplest way possible. By the end, you'll know how AI systems learn, improve, and make decisions, and how this is different from traditional programming, even if you have zero knowledge about it. Let's start with a simple question: what's the difference between traditional programming and AI systems? Imagine you're teaching a computer how to recognize a cat. In traditional programming, you'd write down all the rules to identify whether an input is a cat or not. For example, if it has whiskers, pointy ears, and a tail, it's a cat. Else, it's not a cat. You have to think of every possible detail yourself and code it explicitly, which is difficult. Now, AI works differently. Instead of writing all the rules yourself, you provide the system with data, lots and lots of data. In this case, you'd give the AI thousands of images of cats and images of things that are not cats. The AI system then learns how to identify a cat using these images. So, in traditional programming, you define all the rules and ask the computer to strictly follow it. Nothing more, nothing less. Whereas in AI systems, you feed it with data and ask it to learn and identify the rules or patterns in the data on its own. Let's dive deeper into how an AI system functions. At first, the entire data, which in this case, images, are divided into two sets: training data and test data. Usually 60% of data is used as training data and remaining 40% as test data. Training data is already classified, meaning it has the correct labels attached. In our example, each picture is labeled as either cat or not a cat. The AI system uses this data to learn patterns and rules to identify a cat. This process is called training. Complex mathematical formulas are used during training to identify patterns in the data. After the training, the test data is used to check if the AI has learned it correctly. You show it a new picture it hasn't seen during training, and it tries to guess if it's a cat or not. This helps to measure how well the AI performs. But how does this learning actually happen? Here's how training works step by step. The AI takes each image in training data and make a guess. Then checks the label to see if it's correct. Based on the result, it adjusts its understanding. Over time, it gets better and better at recognizing patterns, until it can identify a cat with high accuracy, even if it's a new picture it has never seen before. Let's make it even simpler. Imagine you're running a bakery, and you want to predict how many cupcakes to bake each day. With traditional programming, you'd write a formula, like, if it's a holiday, bake 100 cupcakes. If it's not a holiday, bake 50. But what if the weather also affects sales? Or a big event is happening nearby? Traditional programming struggles here because it's impossible to write rules for every possible situation. With AI, you'd feed the system with past sales data, including information like the day of the week, the weather, or local events. The AI would learn patterns from this data. Over time, it might figure out, sales go up by 30% on sunny weekends, or rainy days mean fewer customers. Now, it can make accurate predictions without you having to write a single rule. AI can even find out patterns in data that humans cannot and use them to make accurate predictions. For example, AI systems can be fed with test results of thousands of cancer patients, and it can learn the pattern out of it, which can be used to make future diagnosis. The performance of an AI system is directly proportional to the quantity and quality of its training data. If the training data is diverse, accurate, and similar to real-life scenarios, the AI learns well. That's why AI systems improves, as it gets more and better data. It's like teaching someone to drive. If they only practice on empty streets, they'll struggle when they encounter real-world traffic. Similarly, AI needs training data that closely matches the real-world situations it will face. The more data you give an AI, the better it becomes at identifying subtle patterns. That's why companies like Google, which has access to massive amounts of data, often have the most advanced AI systems. The training of AI requires a lot of processing power. Because the AI isn't just looking at a single record at a time. In our example, it analyzes many images in parallel. AI system uses complex mathematical formulas for analyzing thousands, even millions of data points trying to find connections. This is why AI systems often use powerful computers with specialized hardware, like GPUs, to speed up the process. GPUs are great at handling large amounts of data in parallel, making them perfect for training AI models. Without this processing power, training an AI could take months or even years. There are different types of machine learning methods, depending on how the system learns. Supervised learning. This is the most common method, where the AI is trained on labeled data, like the cat example. Unsupervised learning. Here, the AI tries to find patterns in data that doesn't have labels. For example, grouping similar-looking pictures together. Reinforcement learning. The AI learns through trial and error, like a video game character improving as it plays. The amazing thing about AI is its ability to handle complexity. Traditional programming breaks down when the rules get too complicated. But AI thrives in situations with lots of variables and data. That's why it's used in so many fields: healthcare, self-driving cars, customer service, and even creative tasks like composing music or writing stories. For example, AI systems like ChatGPT are trained on huge amounts of data. This allows it to generate human-like responses to questions, summarize information, or even help you with your daily tasks. AI also adapts over time. Think about self-driving cars. They continuously collect data from the roads, learn from it, and update their systems to handle new situations better. This ability to learn and adapt is what makes AI so powerful. So, to sum it up, AI is like teaching a student using examples, instead of giving them strict rules. It learns from data, improves over time, and handles complexity in ways traditional programming never could. The more data and processing power it has, the smarter it becomes. If you found this explanation helpful, don't forget to give this video a thumbs up and subscribe for more fascinating insights into the world of technology. And if you've got questions about AI, or ideas for future topics, drop them in the comments below. Thanks for watching, and see you in the next video.